So let's dive back into quadratic equations. So remember, we had a quadratic equation of that form. Ax squared plus bx plus c is equal to 0. Remember that a cannot be 0, because if a is 0, then it's a linear equation. So gotta remember that. So this is the basic form. We're going to use these variables, the a, b, c, to talk about the quadratic formula a lot. Those are the coefficients in front of those specific terms, right? So a is the coefficient on the square term, b is the coefficient on the variable raised to the 1 power, and c is the coefficient, well, it's just a constant, right? Now, this is the first step when you're doing the quadratic formula. A lot of people like to just dive right into the formula, but what you want to use first is this right here. This is the stuff that's under the root. It's the b squared minus 4ac. And what this tells us is if there's a solution or not, and if there is a solution, how many are there? Okay, so this is called the discriminant. The discriminant. And if the discriminant is less than 0, so if it's negative, then you have no real solution. The reason being is because if we take the square root of that negative number, it's going to be a non-real number. It's going to be an imaginary number. So we have no real solution. If it's greater than or equal to 0, so non-negative, then it will have a solution, and we can find those solutions using the quadratic formula. Okay. We'll talk more about the discriminant. You can see it below right here. I always say it's best to do the discriminant first because you're going to have to do it anyways, right? And it's better to just work on this part than doing this whole formula. So do it first. If you do need to continue on, if you do have a solution, then you just plug in what you found right there. If you don't, then you're done. I think it's the best way to go. All right, the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. That is our quadratic formula. It's going to give us both those solutions. Remember how we would get like when we're doing the factoring, sometimes we would get two solutions. Well, that's why this plus or minus is there. They account for those two different solutions that we would get. Any questions on that? We'll work on plugging problems in and seeing how it works out and all a bit. I just want to introduce you to it now. All right, the discriminant. So this is how you can tell how many solutions you're going to have. If the discriminant is greater than 0, if it's positive, you're going to have 2 real solutions. So if it's positive, you got 2 real solutions. If it's equal to 0, you're going to have 1 real solution. It says repeated solution. So we can say it's just 1 real solution. I bet you I'm writing behind the thing. Oh no, it's right on top of it. Hey. And like I was talking about before, if it's less than 0, if it's negative, there is no real solution. Now, the number one mistake people make when they're working with the discriminant is that b squared. Okay? If b is negative, you square it, it's still going to be positive. If b is positive, you square it, it's going to be positive. So that first term is always going to be positive. Okay? People tend to square, like if it's a -2, they're going to do -2 squared and say that's -4. But no, you need to put it in your calculator with parentheses around it, and then it will give you the actual value, which is positive. So just pay careful attention to that. I just know it's a mistake that happens often. And a lot of people get that there's no real solution because of it. But there is a real solution. Any questions on that? Nope. All right. Let's try one out. So let's say we got 3x squared minus 5x plus 1. Now, if you could factor this, and I'm not sure. Let's see. I don't think you can. But if you could factor this, you could factor it and work it out that way, or you can use the quadratic formula. The quadratic formula is like the end-all solution. If you can't factor it, you can use the quadratic formula. If you could have factored it, you could still use the quadratic formula. It just takes a little bit more time. Even if you could have did the square root method, you could still use the quadratic formula. It'll get you there. Okay. So the quadratic formula is like the skeleton key. It's gonna solve or find that there's no solution for every quadratic equation you could come up with. Okay. So that's why it's good to know. So the first thing we're gonna do is we're gonna label our variables. Remember, we got A, we got B, we got C. The A term is the term on the squared variable, the coefficient on the squared variable, so that's going to be 3. The B is the coefficient on the variable raised to the first power. We retain the sign with it, so it's going to be -5. It keeps the sign. And then the C is a constant that is going to be 4. So they may not always be in order in your problem unless you rewrite the problem. So just pay attention to that. And so the first thing we're going to talk about is the discriminant. We're going to calculate the discriminant, and we can make an assessment on are we going to have solutions or not. If we don't, we're doing no solution. Right. So let's try it out. So remember, the discriminant is b squared minus 4ac. So in ours, it's going to be -5 squared minus 4 times 3 times 1. Oh. So if we work that out, I'm going to have 25 minus 12, which is 13. And I usually box type discriminant. So it's not my final answer, but it's something important. So that 13 is greater than 0, which means that we're going to have 2 real solutions. I'm going to move this. We're going to have 2 real solutions for our quadratic formula. Not quadratic formula, quadratic equation. But we're going to find those using the quadratic formula. Any questions on the discriminant? All right, so let's actually solve this thing. So we know x is going to equal what? -b plus or minus the square root of the thing we just found, b squared minus 4ac, all over 2a. Now, a common mistake people make is they don't put this over to 2a. That fraction bar goes all the way across. I see that all the time. I don't know why. I don't know if they just don't draw it long enough, or then they forget about it, or what's the disconnect. So let's plug in what we got. We know b is -5, so this is going to be -5 plus or minus the square root. We already discovered that it's 13 over 2 times, and a was 3, if I recall correctly. Yep. And so we already know what b squared minus 4ac is. We calculated it before. It is 13. There. Questions there? Okay, so let's talk about what's going to happen here. I don't know if I can get a thing. There we go. We're going to evaluate that negative 5. That's going to become what? Positive 5. Good. I can never write when I'm not told. What was that? We positive 5. Plus or minus. Can we evaluate the square root of 13? Can we take the square root of 13? Get a whole number? No. Can we factor 13 and try to pull out like a whole number? 13 is just 13 times 1. So it's a prime number, can't do anything. So that's just going to stay there. And then we're going to do 2 times 3. That's going to be 6. And that is going to be our 2 solutions. Now, I put that into my math lab. It's going to ask you for the solution set. Your solution set is going to be 5 plus the square root of 13 over 6, comma, 5 minus the square root of 13 over 6. So that is how it's going to ask an answer on my math lab. Any questions on that? No? All right. Here we go. Oh. Next page. Oh, let's give y'all one to try on then. You got 3x squared plus 2 to go to 4x. Notice it's not in that form. Ax squared plus bx plus c is equal to 0 yet. So we got to get it in that form first. So try that one out. Try it out. So to get it to the form that we want, we need to move some stuff over. And the only thing we really need to move is the 4x, right? So we're going to subtract 4x from both sides. And so we'll end up with 3x squared minus 4x plus 2 is equal to 0. And so notice I put the 4x second because I want ax squared plus bx plus c equal to 0. Right? I want that form. So we could try to factor it. I mean, if you want to give it a shot, we can. I don't mind. Just show you what it means when you can't factor something. So AC is going to be 3 times 2, which is 6, right? And B is -4. And so if we try to find numbers that multiply to be 6 and add to be -4, the only numbers that multiply to be 6 are 6 and 1. No way I'm getting a 4 out of that. A 2 and a 3. There's no way I'm getting a 4 out of that. And so that tells me I can't factor that. Okay. So now we'll say, oh, well, let's try our quadratic formula. And so first we're going to do the discriminants. That is not a V, it is supposed to be an R. And so we know that A is 3, B is -4, C is 2. Or the sign comes along with it. Our discriminant, remember, is B squared minus 4AC. And so if we plug that in, it's going to be -4 squared minus 4 times 3 times 2. It's going to be positive 16 minus 24, which gives us -8.
Is that 4 turn into a plus because of...
Come on here.
No. I thought it was before.
This one?
Yeah, we turn into a plus because it is
No, okay, so this isn't based off B. This is just, it's just always minus 4 AC. Yeah. Like, yeah. It's just always be minus 4 times A times C. So we get a discriminant of -8. What does that tell us? That's less than 0, which means no real solutions. And so we don't have to continue at all. We just have no real solutions. So that quadratic equation has no real number that you can put in for that variable that will solve. Any questions on that? This one I'm going to work with y'all because otherwise it is a little tough. I feel like my handwriting works out better when I zoom in as much as I can. So that's what I'm going to start doing. All right, so they start us off with this equation, and it's 9 plus 3 over x minus 2 over x squared is equal to 0. And they tell us our domain x cannot equal 0. So we got to keep that in mind. No, we didn't tell you, so you talked about it. Yeah. I mean, we should have found it, right? There's an x in the denominator, so we know the domain of that variable cannot contain 0. So this is not in the form that I want it to be in, right? It's not an ax squared plus bx plus c form right now. Can I get it there? What do you think? It looks complex, but if you think about it just in what we did with any equation with fractions, right? How do we get rid of those fractions? Multiply by, why would we multiply by 6? Okay, so you're looking at the numerator. You want to look at the denominator. Well, we'll get rid of an x and an x squared. What's the lowest common multiple of x and x squared? Well, if I multiply by just an x, that'll get rid of this, but this will still just be single x on it. You want to multiply by x to the highest power. So what we want to do is multiply both sides of this by x squared. Now on the right-hand side, it's fairly straightforward. X squared times 0 is 0. Right? Anything times 0 is 0. On the left-hand side, it's going to be a bit more complex. The x squared is going to distribute. So let's go ahead, let's write it out as such. It's going to be 9 times x squared plus 3 over x times x squared minus 2 over x squared times x squared. Any questions on that? I'm glad you're back. All right, so let's talk about the 9 times the x squared. Can't reduce anything there. It's just 9 times x squared, which is going to be 9x squared. The 3 over x times x squared. This x will reduce with one of these, but we're still going to have 3 times x left, which is going to result in 3x. And then the minus 2 over x squared times x squared. There, the x squared is completely reduced. And so we just end up with minus 2. And don't forget to equal 0 on the right hand side. Oh, left side, yeah. Okay. So now we have it in the form we want. Okay. This is ax squared plus bx plus c 0 to 0. Got it in our form. Questions on that? All right, so let's work out. Well, first let's label our stuff, right? Let's say, so A is 9, B is 3, and C is -2. Remember to keep the signs with them. Now, let's do our discriminant. So it's going to be B squared minus 4AC is going to be 3 squared minus 4 times 9 times -2. Oh. So a quick little thing that you might notice as you work these is if your A or your C is negative, you're always going to have a real solution. Because it's going to end up being a square term plus something, which is what we're going to end up with here. So you can kind of use that to help you out, but I know when I see that, I always go, oh, it's not going to be no solution. So this is going to be 9 plus what? 72? Is that right? Yeah. That's 81. Oh, okay. That's not bad. You'll see why it's not bad. Or you might know already, but you'll see. So that's greater than 0, which tells me two real solutions. So we know we got 2 real solutions, and so we got to keep going with our quadratic formula. So let's switch to another color. So we know x is equal to -b plus or minus the square root b squared minus 4ac all over 2a. And so let's plug in what we got. X is going to equal, what was b? 3, so -3 plus or minus, we know it's the square root of 81 over 2 times a. A is 9. 2 times 9. Now for this one, I don't need to evaluate the -3. That's just going to stay as is when there's nothing to do. Can we take the square root of 81? It's what? It's 9. So this is going to be 3 plus or minus 9 over 2 times 9, which is 18. And so at this point, if you're able to completely evaluate the root, what I mean by that is the root is gone, it's just a whole number. We're going to evaluate this completely. We can do this arithmetic. It's going to become 2 arithmetic problems. It's going to be -3 plus 9 over 18 and -3 minus 9 over 18. So we just got to calculate that. So that's going to be what? -3 plus 9 will be 6. And we're going to reduce that. -3 minus 9, -12. We can reduce that as well. It's going to be 1/3 and -4. Oh, we can do more of that. Yeah. I was reducing it by 3, but you can reduce by 6. 2/3. So my answer would be the solution set, 1/3 and negative 2/3. That's going to be our answer. Let me check to make sure this is what's back here. Yep. Now, any questions on that? First off, what's interesting about this is if you get an answer where the root evaluates like we did here, where you can take the square root of it completely and the root's gone, what that tells you is that the original problem, we could have factored this. So if you ever do get that, it's kind of a sign like, oh, well, you could have factored that. It would have factored to be what? You can usually figure it out from the answer. 3x minus 1 and 3x plus 2. That's what it would have been. So, yeah. So if you ever do get an answer like this, which can happen, it means you could have factored it. Just a little added trick there. We got x squared minus 4x minus 4 is equal to 0. You're going to get into a tough spot at one point, maybe, and see if you can figure it out. And we'll go over it. The good thing about this one is that it's already in the form, right? Ax squared plus bx plus c. Our a is 1. A is 1. Our b is negative 4. And our c is negative. So first we're going to do a discriminant. I'm going to start shorthanding this. And so that's going to be b squared minus 4ac. And so that's going to be a negative 4 squared, and it's 4 times 1 times negative 4. Looks like we're going to have real solutions again here. So this is going to be 16 plus 16. All right? You get 32. Is that what y'all got? I didn't mess anything up. So that tells us greater than 0, 2 real solutions. And you don't always have to write all that out. I mean, I'm just writing out my thought process. It's a good idea to do it to see what comes with this. So once we know that, let's go ahead with our quadratic. That's going to be x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. And I'm still trying to figure out how we're going to do the test, because I used to give the class this formula, but I don't know how I'm going to do that if you're taking it in all these different places. So I don't know. It's something I'm working on, but just know that. So if we plug in our values, we're going to have what? Negative 4 plus or minus the square root of, we already know it, it's 32, over 2 times 1. And so this is going to be, we don't really write a plus. It's going to be a positive 4, right? Plus or minus the square root of 32 over 2. Now, any questions on getting there? Did anybody do this? Reduce the 4 and a 2. Well, you can't, so don't do that. It's a common error that people do, so don't do that. But what we can do is look at the 32. Can we take the square root of 32? Not gonna be perfect, right? The square root of 32 is gonna be something else. Well, no, I'm doing logarithms. You get 5.6568. But can we split up the 32? Yeah, we can. That's not even read anymore. So we can make this 4 plus or minus the square root of 4 times 4 times 2. Yes. So like what Harley said, since we have a pair of 4s right here underneath a square root, that means I can pull a 4 out. What's going to be left under my root? The 2. So we're going to have 4 plus or minus 4 square root of 2 over 2. Now, what questions on that? Make sure everybody's on the same page. Okay. Now that this term, my numerator is divisible by 2, this term is also divisible by 2, and my denominator is divisible by 2, now I can reduce everything by 2. Okay? If you're worried about making a mistake with that, I can show you the safe way to do it. And that is to look at the numerator and see if you could factor something out between these two. Now they're both have a 4 in them. I can factor out a 4 times 1 plus or minus the square root of 2. And then now we can reduce this and this. You can think of it that way or the other way I showed you. Either way you do it, you end up with the answer 2 plus or minus 2 square root of 2. It's over 1, so we don't need that in the denominator. So if you want to go the safe route, I usually tell people to do it that way. But if you understand that both terms in your numerator need to be able to be divided by that to reduce it, you can go that route as well. Oh, I forgot how to put it into the my math lab. So for my math lab, it'll be 2 plus 2 square root of 2, comma 2 minus 2 square root of 2. One thing to be careful, make sure that the comma is outside the root when you put it there. I know it seems silly, but man, that's a common mistake people do. And it's on a test that you do that, let me know. But on the homework and the quiz, I mean, on the homework, redo the problem. On the quiz, and then you'll be able to let me know that. So just make sure you review your answers. But for the homework, just redo it. But be careful about it. All right, any questions on that one? That tends to be the hardest one, the one where you have to reduce it. That's it for the notes. Let's see what else we got. I think I put this one on its own page. Yeah. So that's a problem I want to use. So let's try some of these then. You can use whatever method you want. You know, we got the square root method. We got factoring. We got the quadratic formula. Anyone you want to use. So try out these 4. We'll give y'all some time, and then we will go over. It's already in the form we want. Notice there's no C term, right? C is just 0 here. You could try to use a quadratic formula if you want this one, but we don't really need to. We can factor the side right here, and it's already set equal to 0. Both of those have a common factor of what? X. So we can factor out X. We're left with X minus 4 equal to 0. So that tells us either x is equal to 0, 4. X minus 4 is equal to 0. This one's solved already. Add the 4 to both sides for this one. Oops. I don't know what I was doing right there. Sorry about that. And x is going to equal 4. And so our solution set will be the set containing 0 and 4. Any questions on that one? Nope. The second one, x squared minus 16 is equal to 0, can actually be worked out a couple of different ways. Okay. Well, it could be done, I guess, 3. You could use the quadratic formula if you want on it. B term is 0, but the C term is negative 6. But you could factor this, right? What is that going to factor to? Anybody know? It's the difference of 2 squares, so it's going to be x plus 4, x minus 4. The other way that we could solve it is we add 16 to both sides. I should have did this in a different color. We'll get x squared equal to 16. And what can we do from there? If you have a term of x squared is equal to a non-negative number, we can do the square root method. And so what you'll get is that x is equal to plus or minus square root of 16 is 4. And so your solution set be negative 4, positive 4. So that way you can work out 2 different ones. Well, that one you can work out 2 different ways. Either way is kind of about the same amount of work. Either way you want to do it. The quadratic formula will take a little bit. Any questions on that one? All right, let's do the z one next. So we have z squared plus z minus 2 is equal to 0. So for this one, can't pull out, it's already in the right form. Nice. It's already equal to 0. We can't factor out a common term, can't do the square root method. Let's see if we can factor it. AC is going to be 1 times negative 2. Negative 2. B is 1. So do I have numbers that can multiply to be negative 2 and add to be 1? It's like a positive 2 and negative 1. Right? Should work. And so we can factor that. It would be z squared plus 2z minus 1z minus 2 equal to 0. Well, I guess you don't have to do this way, but we'll keep going. Because if the a term is 1, you already have a factor from there. But what can we factor out of this pair? There's like a z. And so we're left with z plus 2. If I want to get z plus 2 by factoring something out of this pair here, I would need to factor out a negative 1. This is going to be minus 1. And so that means that this is going to be z plus 2 times z minus 1 is equal to 0. Zero product property applies to that. So z plus 2 is equal to 0, or z minus 1 is equal to 0, which if we solve those, z equals negative 2, and z equals 1. So my solution set is the set containing negative 2 and 1. Any questions on that one? Got that one. And the last one. There's some larger numbers. Oh, okay, that's not bad. So it's in the right form. Can't factor out a common term, no. And we can't use the square root method. So let's try factoring it. AC is going to be 7 times -3 is -21. And B is -20. So on numbers that multiply to be -21, add to be 20. When that's the case, when it's one difference, it's usually going to be that number and 1. But one of them needs to be negative. Looks like it needs to be a negative 20. Questions on that? So this one we have to do the grouping because the a term is not 1. So we have 7x squared minus 21x plus 1x minus 3 equal to 0. What can I factor out of this pair? It's like a 7x. We'll be left with x minus 3. Oh, this is a good one. Now, if I want to get an x minus 3 from my second pair, it's already x minus 3. So I'm just going to factor out a positive 1. So if it's already what you need, you just factor out a positive 1. And so now, x minus 3, x minus 3. What's left over? 7x plus 1. And that's equal to 0. Okay. 0 product property applies here. X minus 3 is equal to 0, or 7x plus 1 is equal to 0. We add 3 here. X will equal 3. Subtract 1. 7x equals -1 divided by 7. X equals -1 over 7. So our solution set is going to be the set containing 3 and -1 over 7. Any questions on that one? Or any of those 4? No? Got it? Okay. All right, so I got one more set of 4. Some of these are simple, and some of these are going to take some work to lead up to the form that you want them to be in, as you can probably see. So you have 2a squared minus 50 is equal to 0. That's an interesting one. The next one, x times x minus 16 plus 63 is equal to 0. You have 6 times p squared minus 1 is equal to 5p. And then the next one has some rational expressions in it. We got 7 times x minus 2 over x minus 3 plus 5 over x is equal to -5 over x times x minus 3. I'll give you a hint on that last one. If you want to multiply something that gets rid of all of those, notice that this denominator is a product of both of these. So we could just multiply both sides of the equation by that denominator there. Give those a shot. This first one looks complex, but it's really not that bad once you start working on it. So the first thing you can do is both of these terms are divisible by 2, right? So you can either factor out a 2 or you can divide both sides of this equation by 2. Either way will get you there. And so if we do that, we end up with just a squared minus 50, oh, not 50, minus 25 is equal to 0. And so now we can use either square root method or we can factor it. If you factor it, it's going to be a plus 5, a minus 5 is equal to 0. If you want to do the square root method, add 25 to both sides. A squared is equal to 25. Take the square root, remember it's plus or minus on this side. So it's going to be A is equal to plus or minus 5. So once you get that one set up, it's not too bad. Any questions on that one? All right, let's look at this one next. Here, to start off, we need to distribute that x. It's already factored, but it's not factored in equal to 0. So it has this plus 63. And so we can't use the zero product property on it, right? And so what we'll do is distribute that x. So we'll have x squared minus 16x plus 63 is equal to 0. We could try to factor that. AC is 63, while B is negative 16. So what multiplies to be 63 adds to be 16, 7 and 9, but they both need to be negative, right? And so this is going to factor to be x, start it again, x minus 7 and x minus 9. And so if we set that up, utilizing the zero product property, we'll get x equals 7 or not. Could have did the quadratic formula if you want on that one too. That'll get you there. Any questions on that one? We got the 6 times p squared minus 1. You go 5 over 5. Well, there's a few ways to do this. Oh, that won't work. Okay, yeah, so what we're going to do is distribute the 6. It's going to be 6 times p squared, which should be 6p squared minus 6 equal to 5p. It's not in that form we want, right? We don't have a 0, we don't have the ax squared plus bx plus c. So we're going to subtract 5p from both our sides. And so we'll end up with 6p squared minus 5p minus 6 is equal to 0. We can't factor out anything common here, so let's do our A, C method. That's going to be negative 36, and B is going to be negative 5. What multiplies to be negative 36 adds to 5, 9 and a 4, with a negative on the 9. And we're going to have to work this out because the A term is not 1. So we have to do 6p squared minus 9p plus 4p minus 6 is equal to 0. What can we factor out? The first pair, 3p. Let's put 2p minus 3. What can I factor out this pair? So I do end up with 2p minus 3. Let's say positive 2. And so what we're going to end up with is 2p minus 3 times 3p plus 2 is equal to 0. Apply the zero product property to that. 2p minus 3 is equal to 0, or 3p plus 2 is equal to 0. If you solve those up, you're going to get what? 3/2. Sorry, I did the wrong. And negative 2/3. And that'll be your solution there. Any questions on that one? And then the last one. This one's a little nasty. We got to get rid of those fractions before we start out. One thing to notice, domain. Since we had those denominators, x can't equal 3. And x can't equal 0. Both of those values would make my denominator 0. And so what we're going to do to get rid of that fraction is multiply both sides by x times x minus 3. So let's see what's going to happen. Well, we're going to have the 7 of x minus 2 over x minus 3 times x times x minus 3 plus 5 over x times x times x minus 3. And then on the right-hand side, negative 5 over x times x minus 3 times x times x minus 3. Let's roll over a little bit. There we go. So let's talk about the reduction that's going to happen. X minus 3 and x minus 3 will reduce there. That's going to leave us with 7 times x minus 2 times x, which is 7x times x minus 2. We're going to distribute that 7x later. You could have did it one step if you want to. We'll do it later. Or I'll do it later. This x and this x will reduce, and so we're left with plus 5 times x minus 3, which we're going to have to distribute. And on the right-hand side, that works out nice there. The x reduces with the x minus 3 reduces with x minus 3, and we are left with negative 5. So let's do our distribution. This is going to be 7x squared. Now the 7x also goes to the negative 2, so it means minus 14x. Distribute to 5, well, plus 5x. It also goes to the negative 3, so it means negative 15. That's still equal to negative 5. We got some like terms to combine up. On the left-hand side, negative 14x plus 5x would be negative 9x. And we're almost ready to factor it, but what we're going to do, we need to add the 5 to both sides to get one side equal to 0. And so we'll have 7x squared minus 9x minus 10 equal to 0. All right, so let's try to factor it, I guess. Say AC be negative 70. B is negative 9. What multiplies to be negative 70 has to be negative 9. Y'all have an idea on that? That won't work. So you can do 10 and 7. That's not going to work. We need something further away. Is there anything else? 5 and 14? Yep. And so we need a negative 14. If you can't find that, you can use the quadratic formula to do it. We'll get you to the goal. And so we're going to write this as 7x squared plus 5x minus 14x minus 10 equal to 0. What can we factor out? That first pair, just an x. Left with 7x plus 5. I want a 7x plus 5 here. So we're going to have to factor out what? Negative 2. And so what we're going to get is 7x plus 5 times x minus 2 is equal to 0. That means either 7x plus 5 is equal to 0 or x minus 2 is equal to 0, which is going to give us a solution set of 2 and negative 5 over 7. Those are both in our domain that we found earlier, so we are good.